We are in the midst of talking about all things database, or at least an introduction to all things database in the ABAP programming language. And as a part of that, here in a few minutes, we're going to introduce a new programming option that we have in the latest version of ABAP that changes things that are available to us and will make our lives as developers a lot easier. But what we left off with, bless you, in our discussion last time was just the basics of writing a select statement and incorporating that into our ABAP program. A couple of things that I would kind of reiterate that's notable about it is the very nice thing about development in ABAP is you have a persistent connection to the database that you don't really need to do anything special to establish. In other programming languages, you might have to have code to log into the database, to select certain attributes of the database that you want to work with. But in ABAP, we just start writing queries, and the system knows where to send those queries because that's part of our overall system configuration. So you'll notice there on line 10 in the code that I'm showing you here, we have a select statement. And preceding that, we just have a couple of data statements to establish an internal table and a related work area, but nothing apart from that. And then you see the syntax on line 11, select, and then a set of fields from spfly, which is a database table. And then you'll notice we did use the syntax here into corresponding fields of table. And there are a couple notable things about that. First of all, the fact that the keyword table absolutely has to be there to let the system know that we are putting our result into an internal table. If the word table were not there, the system would be expecting to put its result into a work area or a single dimension structure, which is going to be problematic if our select statement retrieved multiple items. And then the into corresponding fields of, with our program written in the fashion it is here, is a critical component of this, just to make sure the data really does go into the fields where it is anticipated. And so what that means is, hypothetically, if I change the order of these fields in this statement, it's still going to work out okay, because everything is going to go in the proper place in the internal table based on matching up the names. And this just reinforces the point that we had mentioned in a previous discussion about how our field names in our structure should be exactly the same name and same type as the field names and field types in our database table that relates to the work that we are doing. And so the code that you see here is a pretty typical ABAP sequence where we're going in, and in this case, we're selecting all of the data for a certain set of fields into an internal table, and then just looping through that, producing output to the screen based on iteratively filling a work area with those values. And so here we see the client, the two-letter airline code, the flight number, the from city, and the to city. I didn't put headers over those columns, which I probably should do in a more complete answer, but just to demonstrate the focus of our work here, I think this is pretty straightforward. What we left off with last time was the idea of of how we can build the where clause. And we can have things that are based on strict equality, or we could use the wildcards listed here. So let's just play around with this program here for a moment. If we look at our data here, let's pick something that would be interesting. I don't know that there's anything super notable here, but we could do things like select blah 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 from spfly into corresponding fields of itable, where city from equals New York. And so now we're going to see, assuming I didn't just make a typo, we're going to see this result. We could, of course, introduce or clauses where city from equals New York, or city to equals, oh, that's not an equal sign, equals New York. That's not how you spell York. And so, I'm certainly not going to go through an exhaustive examination of all our possibilities here, but you get the idea of how we can obviously build up a where clause. This is an area where conventional thinking has changed a lot through the introduction of SAP HANA. The rule of thumb has always been in ABAP development to avoid asking the database to do too much work for you. Because the more sophisticated you make your query, the more work you push onto the database engine. And the database engine, keep in mind, has to service all of the clients that are attached to our system overall. And we're already asking it to do a lot of work just with a straightforward select statement. If we start introducing all of this conditional logic, then we're asking it to do a lot of extra work, and that may slow the system down. Well, that might have been an extremely valid concern 10, 15 years ago. But now with high-performance database systems, and in particular with things like in-memory database systems and some of the newer technology that has been brought to bear, the database system is very much up to the task of our throwing fairly sophisticated queries at it. We still really don't want to do a lot of things in terms of advanced analytics on the database unless it is a high-performance database with in-memory attributes and things like that. But we're much less cautious about throwing a sophisticated select statement at it than we would have been a few years ago. Your book talks about a number of things in regards to database interaction that we won't take the time to talk about, but I'll just call to your attention that on page 478, for example, and let's find that real quick, it gives a number of examples of functions that can be used in conjunction with queries. You see average, for example, minimum, maximum, total, count, and so on, and gives you some sample statements with that. So do be aware that there are examples in your textbook that give you more queries and give you more examples. And you'll notice as well that all of these are actually based on either existing SAP tables or SPFly. So if you ever want to, or excuse me, the flight tables. So if you ever wanted to type in any of the code that you're seeing in your book, you should be able to do that and get results that you can play around with. So any questions about this so far? All right, the next thing we're going to talk about is probably the coolest new thing that we have in ABAP, and this is the first time we have been able to incorporate this into this class because we are running on the very newest and latest ABAP execution engine and kernel. SAP regularly updates the syntax of ABAP. The old syntax is always still supported, but as new syntax comes into play, it can greatly reduce the amount of code we have to write or allow us to do newer things. One of the things that was commonly criticized about the old ABAP was just how kind of painful it often was to work with OpenSQL, and how sometimes in your code it became very tedious to write all of the things that were needed in order to set up for effective database interaction. So one of the things that SAP did was update the way you can write things related to database interaction as of NetWeaver 7.4. Now the key thing here is if you start using the new syntax, you have to commit to it wholly in a program. And what I mean by that is you're going to see that the syntax of writing even a select statement changes very, very subtly. But what you can't do is you can't mix and match. You have to decide, okay, I'm going to use the new syntax, and you have to use that in your program. Otherwise, you're going to start seeing errors being generated by the runtime environment. Perhaps the coolest thing that we get is very useful to us in the context of doing database programming, but not exclusively limited to that. And that is what is called inline declarations of data objects with type inference. Now, what do I mean by that? What I mean by that is, if we just focus on the right side of the equal sign here, 7 plus 2, realizing, of course, that in this case, those are hard-coded actual numbers, we would all agree that the result of that mathematic operation is going to be an integer data type. Similarly, if I had variables, but both of the variables here were of type I for integer, we would all agree that the result was going to be an integer. So for me to have a data statement where I say data myvar type I, and then I follow it with myvar equals 7 plus 2, just made me do a bunch of extra typing. So what ABAP introduced was the idea of you don't have to pre-declare your variables. You can create variables on the fly as needed by using the data statement and then putting in parentheses after the data statement the name of the new variable you want to create, and using that in a context where the system can infer what the data type should be. So in this case, two things on that line of code. One is the data object myvar gets created as a brand new variable, and the type is set based on the context to be an integer, and then of course the value 9 is put in myvar as a result of the arithmetic being done. Now in this case, I'm showing this as part of a mathematical assignment statement. But what we're getting ready to see is I can use this in the context of a query to create data objects dynamically without having to preliminarily create them in my code. So this is really, really, really kind of cool. And if we're going to use this in an SQL statement, we have to commit to not only using this, but the other new syntactic elements as well. What are those other syntactic elements? Well, for example, if I have a variable in my SQL statement, I have to put an @ symbol in front of it. So for example, if we go back to this program that we were playing around with a moment ago, and you'll notice I put where city from equals New York and city to equals New York. Well, suppose I changed up my code thusly, and I said parameters city type, we'll make this, well, let's be technical, let's be proper about this, type SP fly dash, and I have a couple choices here. I could make it either the type of city from or city to, because they both trace back to the same base type. So I'll just type city to because it's a less keystrokes. So now what I want to do is I want to change my query here, and I want to say where city from is equal to what the user gave me. And so the user gave me a variable called city, or I want to say or city 2 equals city. Now, if we look at that statement, just focusing on lines 13, 14, and 15, where have I introduced a variable into this statement? Is there any value on lines 13, 14, or 15 that will be different from one execution of this program to the other? Right. And let's make sure we understand this. I'm always going to be pulling out these values right here. That will happen 100% of the time. That is not in any way variable. The table I'm working with will never change from one runtime to the next. I'm always pulling data out of that particular database table. I'm always putting it into this internal table. I'm always comparing it to these fields. What changes is the value of city. So I have to put an @ sign in front of it. Any place where I'm using a variable now in a query, I have to put an @ sign in front of the name of that variable. The second thing that I have to do is my field names now have to be separated by commas. So if I tried to run this code as it exists right now, you're going to see that the compiler complains about when escaped, all host variables must be escaped using @. The variable city is not escaped in ways as the previous host. And it's making reference to the fact it's flagging a syntax error, but what it's really complaining about is that these guys right here don't have commas between them. So let's save this and let's run this by our syntax checker. If the new open and this uses, okay, so iTab, it wants a @ in front of that because that's a variable data object. So basically, what's not hard-coded here, and so now city, and I'll pick Atlanta, and I have no flights going back and forth to Atlanta, so that was a bad one for me to fix. I don't have conditional code in here to test that. We know, though, that New York has stuff going to it, so now I have New York, the flights to and from there. So note what I had to put an @ in front of was the internal table, because that's a variable in the context of my program, and city is a variable in the context of my program. Everything else there are names of fields and the names of database tables. So anything, though, that is a reference to a variable, just in the context of the query, needs to have an @ put in front of it. Notice when I created iTab, I didn't put an @ in front of it. And then down here, when I referenced iTab, I don't put an @ in front of it. But in the query itself, I have to put that @ in front of it if I'm going to use the new syntax. So what becomes really, really cool about this, though, is what I can now do in my program. This is now a fully complete ABAP program. And notice what I got rid of. I have no data statements at the top of my program. I create the internal table dynamically as part of the query. How does the system know what fields should be a part of that internal table? From the select statement, right? I mean, all of the fields that are listed there are the fields of my internal table. How does it know what data type to make them? From the database table. So all of the things before that we had to work out ourselves, now we can just throw this at the computer and we can say, hey, I want an internal table to put these results into, and I do that by just putting a data statement right in in the query. Then notice I don't pre-create my work area. I can just create the work area when I need it. So notice my loop at statement here. Loop at itab into, oh, I need a work area. So let's create it. Data WA. And it's going to create a work area based on the context of my program. It's going to look at my internal table. It's going to see the fields that are there. And so it's going to create a that matches up with that. Now, I only do this, that is the use of the data statement, the time of first occurrence. So notice up here, I use the data statement to create itab. And so after that, itab exists in my program, so I just use it normally. Similarly, if there was more code after this, and I wanted to reuse that same work area, I would just reference it by the variable name WA. It's only the first time it occurs that I put it in parentheses after the data statement. Let's play around with this a little bit and observe how really, really useful this is for us in our programming. So I'm going to go back here, and it's not like my previous program was really all that long to begin with, but we can see that we've significantly shortened it here. And let's go ahead and just run this guy as it is to demonstrate that it works. But what's really nice about this is if we come back and we say, you know what, I don't really need the connection ID to be a part of my program. So I can just delete the connection ID out of the query. I can delete the connection ID out of the output, and I'm done. I don't have to rewrite my data structure. I don't have to change anything up there because the system just automatically does type inference and data structure inference based on the context. I think that's really, 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 really cool, and it's something that's fairly new in just the last, say, year and a half of ABAP development that has been available to us. So you could play around with this in any of the programming that you do in the future, where as opposed to pre-creating your data types, you do them by way of creating them in the context. Now, there are times when you are still going to need to pre-declare certain data objects. For example, in a parameter statement, I'm going to have to use the parameter statement and explicitly define the data object name and the data type, because there's no way for the system to infer this here. But then you'll notice an example that is fairly similar to what we did a moment ago. I asked the user for the flight from, and then if you look at my select statement, all of my fields are separated with commas. City from equals, and then I have the variable flight from, and then I'm dynamically creating the table. And once again, notice now, I've got to be careful here to make sure this says into table, because that explicitly says, okay, this guy right here is in fact going to need to be an internal table. And so this is the way that we'll commonly do this. Note that any data that is a variable has an @ in front of it in the query. And notice as well now, into corresponding fields of is not just not here, it can't be there. The new select statement does not allow into corresponding fields of. And that's because it's unneeded. It knows that it's going to put it in the corresponding fields of it, because that's how it's going to create this internal table to begin with here. So if let's just run this code to demonstrate that it works and give you a chance to see if you have any questions about this. So let's check and make sure syntactically we're fine. So we run this and give a choice here of the different cities, and I need to pick one here that has a flight coming from it. I think maybe Boston. I don't have code here to actually handle if no results were retrieved, which I really should. but for the sake of this example, I didn't put that here. Anybody remember a city other than New York that actually had flights? Okay, Frankfurt. There we go. There's Frankfurt. And so there's our Frankfurt results, okay? So we reduced the code by really the only variable we had to pre-create, if you will, was flight from in the parameter statement. Everything else here uses dynamic data creation in the context of the query or in the context of the loop at statement. Any questions about this?
You said this syntax is only on the newest NetWeaver 7.4.
Mm-hmm.
So if we used to run into a situation working with an older NetWeaver, we'd have to use the older.
Which is why we still cover the older. I think that with your graduating, when you're graduating, the likelihood of you having a company that has the newer engine is pretty high, in particular because ABAP developers go to training or conferences and SAP gets up and says, hey, let's talk about this new syntax. And the developers look at this and say, where have you been all my life? This makes things wonderful. And immediately they come back and start pestering their sysadmins for, we want to be able to write our code this way, update our ABAP engine. And so, whereas a lot of companies will defer updates and patches and other things like that, this is the kind of thing that developer demand likely means that most companies have introduced this. Other questions? All right. Let's talk about something that hasn't really changed. It was part of the old syntax and still is true in the new syntax, and that's the mont field. Mont shows up in a lot of our database tables, and it designates the client associated with a particular set of data. Now, what's really, really interesting is this. Let's say we looked at the flight table that we've been putting around here at, and I'm just going to put up a subset of the fields in that table. So there's the Mont field, there's the city from, there's the city to, and on the board here, I'm not going to put down the flight number and all the other things that are there. This is just kind of a subset of those fields. Well, we're using client 313. So if we were to look at our table, we would see 313 for Mont, city from, I'm just going to abbreviate here, New York, city to Frankfurt, and then we would see 313 city from Frankfurt, New York, and then 313, let's just say hypothetically New York and San Diego, and 313 New York and San Francisco, and so on. Well, when we do a query against that table, the system, by default, will only pull back data where Mont is equal to our client number. So what I'm saying is that every time we write a query, the system behind the scenes automatically appends a where clause to it. And that where clause is where Mont equals, well, where Mont equals what? How do we find out the current client number? SY-MAND is by inference part of every query that we write. And it's part of the SAP data model. And what I mean by that is there are other clients in our system. And they might have in client 314 a flight going from Toledo to Tri-Cities, and a flight from Tri-Cities to Atlanta, and so on and so forth. But when we execute our query against this database table, it only pulls back the ones that match our field. Suppose I want to override that. Suppose I want to write a query and I want to pull back all of the data, not just the data that matches my client. First of all, can I do that? Yes, I can. But I have to change my syntax to allow this. What I have to do is I have to add a client-specified clause to the command. If I don't add the, if you will, magic words client-specified, then every query I run automatically, and for that matter, every database statement of another type that I run, will automatically be limited to just my client number. It's part of the security model. It's part of keeping me from shooting myself in the foot because I am intending to do an operation just for my system, and I inadvertently forget that there are clients that share the same database with me. So this step of requiring me to add this syntax hopefully forces me to be thoughtful about this. So if I use client specified, it would allow a client number to be specified, for example, in a where clause. So I told you that this right here is added implicitly where mont equals sy mont by the system. I told you that's added implicitly. Well, if I add client specified, I could change that. You know, I could, it'd be bad practice to do this, I could hard code in a number where mont equals 112. And then I could execute a query against a client that's different than my client. Or if I use client specified, but I don't in any way limit the client, I basically just cross this out, then I am going to get back the data for all the clients in the database. See, what has been happening behind the scenes here is we look at this code and we say, okay, the system is going to go out to spfly and it's going to pull back, and let's just do this. Let's just clean this up a little bit. Let's get rid of the parameter statement from spfly, and I'm going to get rid of this. So if I've updated my code correctly, we're now pulling back all of the data in spfly. At least that's the way it looks. But the fact is, we're only pulling back the values that relate to our client. And just to be explicit about this, let's add another line of code here. Let's do this right. We'll go to a new line here and we'll write sy db count records retrieved. Okay, and so now let's run this again just to demonstrate that it works. And it says, okay, so you did this and you got back 26 records. And so you might be tempted to think, oh, the database spfly has 26 records in it. That's not the case. There could be 5,000 records in that table because all you're getting back is the ones for client number 313, which is why I put that in the code here. So, based on what we just talked about, how do I change this to get back all of the data? All I have to do is add the two magic words, client specified. So now I'm selecting from spfly. I'm saying client specified, but I haven't used a where clause to specify which client. So it's going to give me back all of the clients. And let's see what happens here now as a result. Look, there's a client 000. There's a client 001. There's a client 300, 303. There's a whole bunch of clients out there. And in fact, when I go down to the bottom now, it tells me 656 records were retrieved. So that is now the full database table. I have now pulled back the full database table, which looks very different than a moment ago. So the question or that you have to ask yourself in your brain as you're thinking about a particular programming problem is, probably the vast majority of the times, you're only going to want to work with your client's information. But if you ever want to span across into another client, client specified gives you the way to do this. Now let's understand as well, we'll later see that this means that if I do an update statement, implicit in that update statement is just update the records that match my particular client. But I can use this to step outside of that particular security model. This also points to something that we will talk about later in the semester, which is you want to create your own table. And you want to have this same security model in place for your table, where different clients can have their own data segregated in the system. How do you do that? Field in your table. And you get that kind of automatically for free based on your having done that. So here is the code associated with this that we just actually incorporated into what we are looking at in the SAP GUI editor. Questions about any of this? Okay. I think this is kind of cool. This kind of data segregation that we get as a part of the security model is something that is very, very useful for us. All right, so no questions with that. Moving along, let's talk about the select loop. What we have seen so far in the select statements that I have shown you is the use of into table. And when we use into table, select goes out, grabs a result set of however many rows that returns, and it puts it into an internal table in one operation. So it goes out, basically grabs a chunk of data, puts it into an internal table, boom, it's done. That is an operation called an array fetch. And it is very, very computationally efficient. But we do have an alternative. If we write our query and our into clause does not specify into table, then what is going to be happening is the query is now going to be iteratively executed. Which means that if I say select blah, blah, blah into and give it the name of a work area, it's going to go out and it's going to grab, let's say, the 87 records that match my query. And it's going to copy the first one of those into the work area and then start a loop. And then at the end of that loop, it's going to go back up and it's going to copy the second record into my work area. And it's going to iteratively, every time it encounters the top of the loop, it's going to put the next result into the data object. This is called the select loop. I automatically get a select loop when I write a query and don't put the results into an internal table. So even though the syntax looks really, really similar, the computational operation is very, very different because we're no longer doing an array fetch, which is a one-time grab a bunch of data, give it back to you in one operation. Now we're doing kind of a singular doling out of information in the context of a looping structure. So we have a loop that starts with a select statement and then ends with an end select statement. So I could do something like this. Select, set of fields here, from spfly into But notice the word table is not there. So now I have a data statement. I'm dynamically going to be creating this data object, and you can tell from what I've named it that I think this is going to be a work area. But the reason why I can think that is not because of the data object name I chose, but understanding the context that if I don't use the word table, I'm getting back just one line of results. One line of results matches up with a work area type structure. So once again, don't have to pre-create the work area, don't need a type statement or a data statement. It's just picked up based on inference. And so what's going to happen is it goes out and it's retrieved, let's say, 50 rows. It copies the first one into WA. It executes this write statement, hits the end select, and goes back up and grabs the next one. And it continues in this fashion iteratively, painting each of these rows. And then at the end, we're going to see output that tells us the number of rows or number of records which retrieve. So let's just look at this by executing this code right here. And while I'm putting this into the ABAP editor, be thinking about the question, why in the world would we ever want to actually do this in our code? So, whoops, object WA, because I pulled it out of PowerPoint, my line breaks moved to different spaces. So let me fix that. All right, so here's my results. Nothing here looks any different in output than if I had done this as an array fetch. So this begs the question, why would I ever do this and not just always use an array fetch? What do you think? Yes, sir. Okay, but I was just displaying the data before. Okay, in this context, I don't have to worry about an internal table. So one of the things that's definitely true is I've avoided creating a data structure that's going to be taking up space and hanging around for the entire runtime execution of my program. So that would definitely be true. Anything else you can think of? Let's look at, as an example of this, let's look at the fields that are actually in spfly. And let's see if we can work with spfly to see a good illustration of this. So spfly display. Okay, good. You'll notice that we have, for example, here departure times, arrival times, we have distance, we have a lot of very interesting fields other than the ones that we have been working with here. Well, suppose we wanted to calculate the duration of the flight. And you'll notice, pretend that flight time isn't there. But notice we have departure time and we have arrival time. And so we wanted to figure out the duration of a flight by subtracting departure time from arrival time. Okay, you got what I'm suggesting here? So if I go back up here to the whiteboard, what I'm saying is, and I'm going to write this off to the left because I am too close to the edge here. So depart, arrive. So this would be like depart 1:15, arrive 3:30. Depart 2:30, arrive 4:15. So let's assume we had the flight times for every flight. And suppose I told you what I wanted you to do is I wanted you to produce output that displayed the city from, the city to, the departure time, the arrival time, and then the duration of the flight, and you had to calculate the duration of the flight. Well, think about how we have been doing this to this point, where we go out and grab the entire table. So essentially at this point now, you would have this entire table, but in the context of your program, the duration. So that's something you're going to have to calculate. How are you going to do that? Well, you're going to have to go through this table row by row, doing the math, calculating that data. Or you're going to have to step through this table row by row, and as you output every individual row, you're going to have to calculate duration at that point. But the fact is, you're going to have to visit every one of these rows a second time in order to do the calculation and create the output. So what a select loop allows us to do is to incorporate that operation into the retrieval operation. So I retrieve the first record, I calculate the duration, I write the output. I retrieve the second record, I calculate the duration, I write the output, and I proceed in that fashion, as opposed to filling the entire table and then looping through the entire table in memory and calculating duration, basically processing the data a second time. Yes, sir?
Which server is doing the calculation for you, the application server or the database server?
It's a really, really great question. The database server in this instance is returning record one at a time. The application server is the one that, in my example, would be doing the calculation of the duration. Now, if you're saying, well, couldn't we write a very sophisticated select statement that would do the calculation as a part of that? That might be a possibility. And then in that case, the workload would be shifted to the database server. But your question also points to something else we should be thoughtful about. What this does is this changes the way the application server interacts with the database server. If we use the analogy of a phone call, what used to happen was you called up the database and said, select blah, 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 blah. And it picked up the phone and it said, here's your results. And it sent you all the results back in one burst of communication and then hung up the phone. Well, when I use a select loop, you call up the database and say, give me this, and the database says, okay, here's your first result. And then it sits there waiting for you to finish your loop, and then it says, okay, here's your second result. Okay, here's your third result. And your line of communication with the database is kept open for the duration of your select loop. For that reason, use of the select loop, even though it is something that you still see incorporated into ABAP programs, is considered, while not considered obsolete, it is considered something that you should avoid unless it really makes sense computationally in the context of what you're doing in your program. So you will see these. You may have occasion to write these, but in general, this is something that you want to be very, very careful about actually incorporating into your program. Questions about this? There is one other variation on the select loop, which is we can actually select not into an internal table and not into a work area or structure. We can actually just select into individual variables. So let's look at this particular query. Select mont caret id conid from spfly. I put client specified here just to illustrate that syntax into. Notice no table is listed. And notice now we have another kind of interesting coding convention. After the word into, there's an opening parenthesis. When the system encounters an opening parenthesis, it says, oh, this is not going into an internal table, and it's not going into a work area. It's going into individual variables. And so in this case, I'm dynamically creating a variable called client that it's going to put mont into, and I'm dynamically creating a data object called caret that it's putting caret into, and I'm dynamically creating a data object called conid that is putting conid into. Now, the whole reason why in this example I used client here with the at data is to illustrate that the names don't have to match. The names can match and commonly should match, as I'm showing with the second and third data objects that are listed here. But all that's going to happen here is it's going to count 1, 2, 3 data objects. And it's going to put the first one in the first one, the second one in the second one, and the third one into the third one. Now, I could have pre-created those variables with a data statement before this select, but since we now know how to use dynamic data object creation, I decided to incorporate that into this example as well. So what we observe, there are 3 ways that the system will execute a select statement. If I select into a table, it will put the whole thing into an internal table in one operation called an array fetch. If I select in, don't put parentheses, but also don't use the word table, then it knows that it's putting that into the equivalent of a structure or a work area, and it is doing so iteratively in the context of a select loop. If the into clause uses an opening parenthesis with a set of variables listed, then it knows that once again it has a select loop, but now it's not going into a structure or a work area, it's going into individual discrete data objects. Questions? This raises the very obvious question, why in the world would you ever want to do this? Anybody have any theories about this? Before we had the dynamic data statement, this kept us from having to define a type for a structure and do all of the pre-work that we have to do with setting up a structure. So that's off the table. So now that further raises the question, why do we want to do this if we don't have to do that? The best answer I can give you is, you'll notice now in my write statement, I don't have the repeated reference to a work area, and I'm not saying, WA-client, WA-whatever. So if I were going into a database table and I was only pulling out, let's say, one field, this might really make good sense. So let's go back to our code in our ABAP system, and it looks like the system has done what I hate for it to do, which is that it has, oh, there we go, I got it back. All right, so, well, I thought I got it back. Let's try that again. Restore. All right, so let's just say, for example, all I wanted to pull out is, I asked you, where are all the places we fly from? So all I care about is city from. I don't care about anything else. Well, in this context right here, is there any reason at all why I need a work area? I mean, a work area is totally useless here because I'm only pulling out one particular field. So in this case, I can do this, into at data, and we'll just call this city, and then write city. So clearly my code is a lot more straightforward here, and in fact there's all of my cities that I fly to. What do you notice about this list right here? Is that, properly speaking, a list of all the cities I fly to?
Only your client.
Only my client, that's true. But this leads me to believe that I fly to 26 different cities. Do I fly to 26 different cities? I do not. So what do I need to do to fix this? Any database people remember how to fix this? What just happened there? Ah, my cursor was in the wrong place. Oh. So here's an example of something you already know from database being still possible for you to use, and your textbook talks about that in the section that talks about functions that we talked about a moment ago, but realize that you can and should leverage things that you already know from your database course. So notice the point of it was, in this situation, I was just producing a single set of fields. To use an internal table, even to use a structure here, would only just complicate this code. So by using into with the parentheses, I can put it in a single data object, a single variable, and life works just fine. Yes, sir? So that I can have one database server that can support many different clients. Meaning that if we think about what's actually happening right now, our server, both the application server and the database server, are sitting in a data center in Milwaukee, Wisconsin. If we did not have the ability to segregate data based on clients, we would require our own application server and database server just for us. But by allowing the data to be tagged by client, we create something that is actually very, very useful in contemporary computing, which is support for what is commonly called multi-tenant. I'm not sure if there's one N or two N's in tenant, so I'll put a parenthesis around that one, okay? So what's a multi-tenant? Multi-tenant is the idea that you have multiple different entities sharing the same infrastructure, but are each using it as if it were totally unique to them. So this same ABAP system is in use by, it appears to me, about 8 or 10 other universities. But they don't want what they're doing to interfere with us. We don't want what we're doing to interfere with them. So this gives us a way to make that happen logically. And in our case, I've shown you over. I tell that the system administrator can configure the system such that even if I try to reach beyond my client, it would be blocked. But our system allows us actually to do that. This idea of a multi-tenant system is very, very common these days in cloud computing. And in fact, SAP now sells products to companies where the server is in the cloud, it's owned by SAP, it is a very, very large, powerful system, and there may be 40 or 50 or more small businesses that are all sharing that system. But every one of them has absolute segregation of their data based on this principle, even though it's in the same database tables. It looks like your data is separate from everybody else's, but if you were a system administrator and you went in and actually looked at the database tables from a database server perspective, you'd see your data and everybody else's kind of commingled there together. So this is actually extremely useful and very, very practical in cloud computing and a number of other contexts where you want one computing resource to be shared by a variety of different people. It's kind of the same idea as you go to the lab and you log into a computer and you have a My Documents folder that just has your documents in it. Somebody else logs into that same machine. They can run the same programs you can, but their My Documents folder maps to a totally different set of data. It's kind of the same idea as far as the logical distinction. Other questions? It's a good question.
I have a question on the PowerPoint slide.
Okay.
Particular, the at data client. So you selected the Mont field, which is your client ID, and then you said client specified into, and I have here that that's
If I put client specified, it's going to give me all of the clients.
Exactly. And so, but the purpose of select in select, excuse me, you write client instead of mon.
Right.
Okay.
And that is just to let me, I think I have code. I could do this. It's not going to make for very pretty code, but I could use X as my data object name here. And this program is going to work just fine. So all this is doing is this says, okay, I know I'm going into, because I see an opening parenthesis here, I know I'm going into an individual data object. I'm not going into a table. I'm not going into a structure. I know I'm going into an individual data object. So what's the name of that data object? And I just elected to call it X here. Perhaps to make this a little clearer, I could do, and all I've done is save code by writing it the way I have, but this could be data X type spfly dash city from. Got to put a period at the end of that statement. But this is now exactly the same as what I had there a moment ago. Okay? And let's make sure that I'm not telling you a mistake here. Yep, works exactly the same as before. Okay? So I would want to get in the habit of matching my names up to make my code clear. Clearly, X is a really bad variable name here, but it's just illustrating the fact that the name is not what's important here. It's the fact that I only have one thing listed, and it's here. If I did Y and put select distinct city from, comma, city to, and put X, comma, Y here, it would put city from into X and city to into Y. Okay? Other questions? Yes?
Still based on that, since there's three objects in your parentheses there in PowerPoint, I'm assuming since you didn't maintain the same name as the field font, that it's going in order. It's listing the information it collects from the database by order of which you're listing your
Yes.
objects in the.
Yes. Absolutely so. Which means that if I made a mistake here and put @data conid first, I now have kind of a logical disconnect because, now I've got mont going into conid, and, I have a recipe for confusion there.
If you match the field names, even though it's not in order, will it still know put those into what you're looking, so it goes strictly by order?
It's going strictly by order in this situation.
Specified and don't use a where clause. Are you not running a similar risk of select star?
Okay, hang on a second. Run that by me again.
Okay, so you're pulling all the client information for the table SB. Depending on the table, if you're not saying a where client equals 314, if you wanted to see that information, are you not running the risk of pretty much running a select star in a different way?
It's not a select star in that it's not pulling all of the fields, but it does have commonality with select star in that it's pulling all of the records. So this is a very, very, if you ask me, why did you make client specified here? There's no reason for that other than just to illustrate that it's possible. Your use of client specified is going to be very, very rare. Let's say hypothetically I asked you to compare the records that were in client 313 with the records in client 314 to see if you saw any discrepancies. Well, you're going to have to use client specified in that statement because you're going to have to reach beyond just your client. But the vast majority of times in a production environment, you're going to be looking at just working with your client. Okay? Other questions? Yes?
On that example you just give, is it, form of speaking, is it better to do like a nested select statement looking for both of those different clients and comparing them? Or would it be better to put them both, like do a select, put the output into the internal table, do another select, put client 314 and put that into the table, and then compare the two tables?
You're going to have to figure out what the basis of the discrepancy is. I mean, what I suggested as being something really simple actually has some pretty significant complexity to it. What you'd probably have to do is pull the first record off of one of the two clients and then do a select into the second client to see if you found something that matched up with every one of those fields. And if you did, then you've got a match. If you don't, then you know you have a discrepancy. So I think you could probably do that in the context of a select loop with a just internal logic. But then you have the issue of that would tell you for all the records in client 1, is there a match in client 2? Now you would have to address, is there something in client 2 that's not in client 1? So you'd kind of have to do the same thing going the opposite direction. So that might actually be 2 back-to-back select loops. There might be an easier, that might be a situation where you'd almost be better off pulling both result sets, pull one client into one internal table, another client into another internal table, work with them in the context of internal tables, and see where that left you. I could envision hypothetically logic where you took the first record off of one of the clients and used it to delete things out of the second internal table. And then when you were done, you looked to see if there were any records left or if there were any deletes that failed because they didn't have a match. The logic of that would be really interesting, but I just picked that example off the top of my head. All right. Other questions? All right, well, I think we have, I think actually this represents a good stopping point because the next thing we're going to talk about is the insert statement, and we only have about 5 minutes left in class, and so we wouldn't have time to get through all of it. So we will pause here for today. I do feel pretty good about the fact that we should be able to, in our time on Thursday, wrap up the core of things related to working with database tables and be on track for our midterm exam coming up